Hello, my name is Santiago and I'm going to talk about recrystallization. Well, first, three terms are important to know for this process: solvent, solute, and solution. Solvent, that's a part of the solution which is present in larger amount. The solute, that's a part of the solution which is dissolved in the solute and the solvent, sorry. And solution. The word solution is used to describe the liquid or solid phase containing more than one substance, and it is also a mixture of the solid and the solvent. Recrystallization is also known as fractional crystallization. It's a procedure for purifying an impure compound in a solvent. Recrystallization is based on principles of solubility. Compounds, solutes, tend to be more soluble in hot liquids, solvents, than they are in cold liquids. If a saturated hot solution is allowed to cool, the solute is no longer soluble in the solvent and forms crystals of pure compound. Impurities are excluded from the growing crystals, and the pure solid crystals can be separated from the dissolved impurities by filtration.
Even though crystallization and recrystallization processes are really alike, they are different. Crystallization refers to the formation of a new insoluble product by a chemical reaction. Typically, crystallization is a method used to obtain the crude product. Recrystallization does not involve a chemical reaction. The crude product is simply taken into solution, and then the conditions are changed so crystal can reform. This produces a much purer product. Recrystallization is not generally thought as a separation technique. Rather, it is a purification technique in which a small amount of an impurity is removed from a compound.
How to choose a recrystallization solvent. A successful recrystallization depends totally on the proper choice of solvent. The compound must be soluble in a hot solvent and insoluble in the same solvent when it is cold. For the purpose of recrystallization, we consider 3% the dividing line between soluble and insoluble. If 3 grams of compound dissolves in 100 milliliters of solvent, it is considered soluble. If not, it is considered insoluble. For example, compound A is soluble in boiling water, but not in cold water. Therefore, water will be a good choice for a solvent to recrystallize the compound. Otherwise, if compound A is not soluble in either hot or cold excients will be a poor choice to recrystallize this compound.
As I said before, recrystallization is used to purify compounds, and an industrial process uses it, like in a sugar factory. They crystallize saccharose from the sugar cane, and then they purified it by recrystallization to obtain a purer form of sugar. That was an example of how this technique is used in the big industries, but it can be also used in the chemistry lab every time a solid needs to be purified, just like when acetyl salicylic acid, also known as aspirin, has just been synthesized. It can be recrystallized to obtain a purer result, isolating impurities. Now I'm going to show you how to do the recrystallization of an organic compound. The equipment is needed consists of a pipette, a flask containing the compound to be recrystallized, a hot plate, a flask with recrystallizing solvent and boiling chips, and an assembly for doing a hot filtration. This consists of a steamless funnel, some filter paper, and another flask for receiving the filtrate. First, we begin by warming the recrystallizing solvent and the filtration apparatus on the hot plate. We want to adjust the hot plate so that the recrystallizing solvent is just barely at a boil. We need to work on the hot plate so we keep everything near the boiling point. We add a couple portions of the solvent to our compound, and we need to swirl the flask keeping in contact with the hot plate to help dissolve the material. The goal is to add just enough solvent to make a saturated solution and then a little excess. Some impurities will be completely insoluble, so don't add too much solvent. So we continue adding the solvent. As you can see, the solution has a slightly yellow cast. We can remove this color by treating the solution with activated carbon, then swirl and warm it again on a hot plate. So just like I said, we're adding activated carbon just to remove the yellow color in our solution. Next, we filter out the insoluble impurities through the filter paper into the warm flask on the hot plate. After most of the solution is strained through the filter paper, use a couple small portions of the hot recrystallizing solvent to rinse the paper. Now the solution is removed from the hot plate and allowed to cool to room temperature. After the flask reaches room temperature, we have a reasonable crop of crystals. As you can see, crystals are all over the solution. But we still need to transfer this to a water bath to complete the recrystallization process. We'll collect our crystals by vacuum filtration. To do this, we'll need a Buchner funnel, a filter flask which we have clamped to the ring stand and attached to the aspirator at the workbench, some cold recrystallizing solvent, which we have chilled in the ice bath, and a searing rod. As you just saw, we also need to fit the Buchner funnel with the neoprene adapter and then add the correct size filter paper. Turn on the vacuum source and then wet the paper with the recrystallizing solvent. Then, wash the crystals in the Buchner funnel with a small amount of cold recrystallizing solvent to remove any supernatant liquid adhering to them. Keep doing this to get as much crystals as possible. Then, wash the crystals in the Buchner funnel with a small amount of cold recrystallization solvent to remove any supernatant liquid adhering to them. Finally, we initiate the crystal drying process by pulling air through them for a few minutes. After that, they are transferred to a watch glass and left in the open air for a time to dry completely. So, at the end, if we did everything correct, we should get something like this, a real pure solid. As you see, our experiment is finished and I hope you liked it. Thank you for watching.